There we go.
Yeah, welcome everybody to this week's Azure and AI show. We should have a couple of other speakers joining us shortly, but this week we have Sajida, and she's going to do a session from Copilot to AI agents, a practical guide to choosing automation tools. Then we should have Seena, and she's going to do a session on data-driven microservices for finance, performance, compliance, and AI at scale. And then we have Arun. Arun is here on the screen. He's going to do a session on cybersecurity in the AI era, trust and resilience on Azure. And then we have Sahara, and he's going to do a session on carbon-aware AI on Azure, intelligent workload optimization. And then, there we go, we have another speaker joining us there now. And then we have Ravi, and he's going to do a session on Azure AI-driven self-healing real-time streaming architecture. Very good. And we have Hal, who's with us, veteran MVP. He's a Microsoft MVP for 30 years. And Hal is joining us there from the US. So, Aaron, I think you're first up on the list.
Thank you. Thanks, Frank.
I have your screen up there now. Yeah, we can see it.
Hello, everyone. Hope everybody is good in the hot summer. So this is Arun. So I work in a reinsurance industry as a cybersecurity operations manager. So I manage all the cybersecurity team in my current company. So I'm going to talk about cybersecurity in the AI era. It's a huge change for us, right? So for around 20 years, we secured systems that did exactly what we told them. But now we are securing systems that decide what to do on their own, right? So it's a big change. So everybody thinks it's a version of a old problem, right? Like we should evolve and fix that. But this is a different problem which we should address. And in the upcoming slides, we will see how we are addressing this different problem. So yeah, so it is a different problem, as I said, but it's not a bigger one. Okay. So in the AI era, the instructions themselves are untrusted. So like in the past, the attacker breaks in and the code is compromised and the data is exfiltrated. So it's a sequence which we identified and which we know what to do. But in the modern era, it is the instructions themselves which are untrusted. The attacker doesn't break in anymore. They just leave a note where your AI will read it and execute it as the attacker said. Um, so we spent a decade teaching people not to click the link, but now the AI clicking the link. Okay, so it cannot be fixed by a security training. Okay, so we should fix it by the controls around it and the security um, tools and platforms what we can put in to enable all the controls. So what are the threats that live inside the prompt, right? So AI is basically the prompts what we are giving, and the one that gets me is the memory poison, right? So with the agent, that remembers across sessions. An attacker plants a false fact today, and the AI faithfully acts on it weeks later. Okay, the chat was closed like months back, but still the memory stays with the AI. Okay, and it can execute it when the attacker instructed it to do so. You know, yeah. So the prompt injection is a headline one. Hidden instructions in an email or a doc that the AI treats as a command, which is a threat to us today. Okay, this threat doesn't haven't existed in the past, which is new to us. Okay, and then the lethal trifecta. Okay, so what it means? So you are in a trouble the moment an AI can do three things at once. Okay, so it can reach your private data, it can read your untrusted content from the outside, and send information elsewhere. So all three can be done at the same time by the AIs. Okay, so it's kind of a zero click attack. Okay, so today somebody has to click something, so it leads to a compromise. But this is like the AI can reach your private data today. It has access to it, and the untrusted content like email, docs, and pages from the outside world, right? So it has access to that, and it also has the access to send your data out to anybody if you are not controlling it. So you can pattern this. Okay, so it's not that AI is all unsafe, right? So it is unsupervised by default. So when you create something, let's take a AI service, right? So when you create a AI service, by default it is unsupervised. Okay, so you should not treat that as a tool or a platform. It's kind of a new employee who doesn't have any training, and it can move faster into the environment, right? So that's how you should treat AI. So you wouldn't hand everything to the AI when you onboard it on day one. Okay, so that's like giving the keys to the new employee on day one. Okay, so yeah, so let's see how we can design and not to do in these use cases. Okay, um, so trust isn't a feature you bolt on at the end, right? So it is an architecture you build from the first line of code. So the moment you decide you need to bring in an AI service into the environment, you should have a design where it has a owner, a least privilege access to the systems, data boundaries inside it, and the AI doesn't know your org chart. Okay, so you should draw the line where it should reach, where it should not reach. Okay, and the guardrails on both the sides. So you should define the guardrails like who has access to it, who can interact with it, what data it can access, what data it can send to anyone. Okay, so you should control it, design it even before you bring in an AI inside your environment. Okay, so that's critical. Okay, and then um, the visibility, right? So the initial design. Okay, so it starts, and then what's the next one, right? So you should have the visibility, how the AI is interacting with your environment. So it reads data, it writes data, and it sends data to people within your organization and outside of your organization. Okay, so there are controls and it can be enabled. For example, Microsoft has a Defender for Cloud and it has the XDR solution. So if a Copilot agent is deployed in your environment, you can monitor it, and it can be like it can be controlled through Microsoft features which they enable out of the box today. Okay, so one good example, right? So we do have native controls today. So the Copilot agents have agent identities, which is like a user ID. right? So as I said, it's like a new employee. So you need to have a life cycle management around the AI systems. Like when you bring in a Copilot agent, it has a agent identity by default, which is like a user ID. So you can put all your controls on top of it. Like what is the data classification it can access? What is the least privilege it should have to do its job, and what kind of data it can send out and send to people who should access it, right? So that those are all defined by the design, and it's from the inception of the agent itself. Okay, so it's basically identity driven, and one key point is you can kill that identity if you feel like it's a threat. Okay, so that's the key here. Like when an agent has an identity similar to a user ID, you can disable it, and that's it. So all your access, all your guardrails will be applied based on the identity, what you have defined and designed. Okay, so these are the native controls mapped, right? So as I said, identity for agents. Okay, so we have Entra Agent ID and Agent 365 today, which will control all your Copilot agents, Studio agents, the agents deployed through AI Foundry, and then there are agents which are deployed by individual user through M365. Okay, so all those visibility is through Agent 365 today. And data classification as well. You can tell which agent identity should access what type of data. So that's possible today with Microsoft Purview. And then input output guardrails, as I said, the AI content, safety, foundry. So all those controls or guardrails are defined using the native controls today. Defender for Cloud can be enabled for the runtime, so you can identify memory poisoning. So you can control all the prompt if somebody tries to compromise the agent. Okay, so that can be controlled through Defender for Cloud, and it will enable you to have the visibility as well. What kind of attack is happening to the agents today. Okay, and posture management, again, different for cloud can be enabled for posture management, so it will monitor what's going on in the AI agents, and if any vulnerability or anything is detected in the agent itself, it's going to tell you. You can see the different for cloud dashboard or the XDR dashboard to find out that. Network isolation, again, based on the identity, you can create private endpoints using Entra ID authentication by default, which has MFA and all those stuffs. So yeah, so network isolation is possible as well using native controls in Microsoft today. So yeah, so there are regulations today which has all these controls defined, from overview perspective, right? So we have OWASP top 10 for LLM, so which we can take a checklist and then implement that in the environment to control to put all the best practices on top of the LLMs. And then MITRE Atlas. So what are the attack techniques today the attackers are using to compromise an AI? So that can be got through MITRE Atlas, which has very good data. And then NIST AI frameworks. So you can refer all the NIST AI frameworks to define a structure, to define a design. So what are the best practices we can follow? And then from a compliance perspective, we have all the EU AI Act and then GDPR regulations. Different countries have different regulations now, so you can refer all those controls in EU AI Act and ISO 42001 as well. So and this is interesting, right? So we spoke about um, cybersecurity for AI, and we should also discuss AI for cybersecurity. So we can utilize AI so much that it can help your cybersecurity team to analyze logs, to find anomalies, to enhance your cybersecurity posture today to extent, right? So to enhance your current cybersecurity posture. For example, Microsoft has all the Copilot agents in cybersecurity. So they have Security Copilot, which is enabled through E5 today. So that has phishing triaging agent, which is going to help all the cybersecurity team to triage the phishing um, uh, uh, emails. And then we do have conditional access policy evaluation agent, so which is part of the Security Copilot. So yeah, we Microsoft enabled us with all these security features using AI agents, which can be used. So in the slide, you can see, right, like a human cannot possibly sit for like 24 hours and read all the logs and give us the outputs. It might take 7 days for a resource if he is going to do that. But a AI agent can read the logs like 24/7, right? So which is a huge enhancement today, which eliminates the resource constraints what we have in cybersecurity. It can send alerts. It can automatically remediate few of those alerts. So it's all huge futures today with AI for cybersecurity. Yeah, finally, yeah. So trust is a design decision, right? So and resilience is a discipline. Okay, and on a platform like Azure, um, we can build a lot of things. But anything you build should be based on these principles. So instead of just assuming that everything will work, so we should design it and implement that properly with all the controls, native design controls, what Microsoft enabled us with, and then look for cybersecurity team to use those controls and make sure the environment is secure and safe. Yeah, so that's it from me today, Frank and everybody. So if we have any discussion points, we can discuss around this.
Yeah, very good. Um, nice to see some AI stuff in cybersecurity anyway. Anybody, any questions for Ron? No, you're
Oh,
good. Hang on.
Were you running on a Mac or was that a PC? It looked like Windows 11, but then PowerPoint looked like it had the Mac stuff on it.
No, this is Windows.
Okay, cool.
Yeah.
Okay.
Good show.
Thank you.
Very good. So, Sajida, do you want to share your screen?
Sure, I'm sharing the screen.
Yeah, we can see it there now, yeah. From Copilot to AI agents.
Okay, you see my screen, right?
Yeah, yeah.
Yep.
Okay. Hello everyone. Good afternoon. My name is Sajida Sultana and I am Microsoft Certified Trainer. So today my session topic is from Copilot to AI agent, a practical guide to choosing the automation tool. So over the past few years, we can see that AI has become one of the most discussed topic in technology, right? So organizations are investing heavily in AI solution, and we have now the multiple options available, such as Copilot, workflow, AI agents, agent flow, and so on. So the challenge today is not whether we can automate something. The challenge is choosing the right automation tool for the right business problem. So sometimes a simple workflow is enough. In other situation, we need an AI agent that can respond and can make decision, understanding the difference, and because it helps us build solution and they are effective, maintainable, and scalable. So by the end of this session, I am hoping you will have a practical framework for deciding when to use Copilot, when to use workflow, when to use the AI agent, and how agent flow fit into the overall structure. And I will show a live demo. Okay, so before we jump into the demo, let's take a look at today's agenda. We will begin discussing what is the evaluation of the automation, how organization has moved from manual process to the intelligent system. This will help us to understand where the Copilot and AI agent fit within the broader automation landscape. So next, we will explore some of the basic concept. Let's say what is the Copilot, what is AI agent, what is the difference between the workflow versus the agent flow. And then we will discuss about the framework when we should use what type of automation. I will show some of the real world use cases. Then I will describe the workflow. Then we will go into the live demo. Okay, so to understand the evaluation of automation, we need to know where the AI agents fit today. So it's helpful to look at how automation has evolved. At the beginning, most business process was the manual, right? Employed entered the data, processed the request, and then made the decision themselves. So this process is worked, but it required the significant time and the effort. Then the evaluation was workflow automation. So as the organization grew, workflow automation became the popular workflow, allowed the business to automate the repetitive and the predefined tasks. For example, when a new file is uploaded, let's say within the Outlook, then send the automation or send the notification to the teams. Or the another example, let's say when a form is submitted, then create a record and send the thank you email. This kind of automation is the workflow automation. Then the evaluation now it's happening, it's the AI assistance. So today we are moving beyond the traditional automation. So we have now the Copilot that assists the users and the AI agents that can reason and make decision. The evaluation mainly represents the shift from the simple manual process to the AI assistant process. Let's try to understand some of the basic concept. What is Copilot? So, Copilot is the AI powered assistant designed to help the users to complete the tasks more efficiently. So, think of Microsoft 365 Copilot. It can draft the email, right? It can summarize the meeting, it can create the presentation. Also, if you upload any file, you can ask any question. If the information is available, it can answer. It can able to answer your question, right? But the most important things to understand when the every time the user remains in Copilot, right? Copilot provides the suggestion, recommendation, but it doesn't independently make the business decision. For example, Copilot can draft the email for you, but still you need to decide whether to edit, whether to approve it, or then you have to tell the Copilot, okay, send it, then it will send, right? You are the decision maker. Let's go to the next basic concept. It's a AI agent. So many people think the AI agent is the simple another chatbot, but it's not true. It's the AI agent is much more than that. A chatbot mainly we can say it can typically answer the question based on the predefined information. I'm mentioning the word predefined. That means all the steps is already mentioned. But the AI agent can understand the goal. It can reason about the available information. Then it can decide what will happen next. So let's take a simple example. Let's say for IT support, Maybe a user can ask to the IT support agent, okay, my laptop screen is not correctly showing the correct screen, or maybe my screen showing the blue. So a chatbot may be simply return all the troubleshooting information, but an AI agent, it can analyze the exact issue, it can mark the best solution, then it will send the information to the user. That means it's not the predefined, it's just trying to find the best information that it's showing the information in front of the user. So this is the AI agent. Okay. Let's try to understand what is the difference between the co-pilot and the AI agent. Now you have some idea about what is it, right? So let's compare them. Both co-pilot and the AI agent use the AI capabilities, but they serve the different purpose. Co-pilot mainly focus on helping the user, that means it's a user assistance, and the AI agent, we can say it focus on the achieving the goal instead of waiting for the instruction of every step. AI agent can determine what needs to do next. It can analyze the information, it can evaluate the different type of option, then it decide the best action. So we can simply say the difference is Copilot helps the people to work efficiently and the agent work towards the outcome. So both are valuable, but choosing the right one depend on the business scenario. Let's try to understand what is workflow. So a workflow is the predefined sequence of steps that is triggered by the specific event. So uh, here the word is the predefined, right? Defined series of steps. That means it's a predefined step. So we are already know exactly what should happen next. For example, when a customer submit a form, it can create a record in the data first, then it can send the confirmation email. So every time the same event occurs, right, and the same process execute, there is no reasoning or there is no decision making is required. So the path is already known. In that cases, we can create the workflow. Then the next basic concept is the agent flow. What is agent flow mainly? So this is one of the concept that often the cause confusion, because agent flow and the workflow is very similar. Both perform the same things, but we need to choose the based on the business scenario. The difference is the workflow is start when the event occurs, and the agent flow start when the agent decide what action is required. And the trigger is for the agent flow, the trigger is the decision making, and the workflow, the trigger is the event driven. Okay, let's try to understand what is the difference between the workflow and the agent flow. So the workflow I already mentioned, it's triggered by an event, and the agent flow is triggered by AI agent decision. And the next difference is the workflow always maintain the predefined steps, but the agent flow, it depends on the agent decision. If agent thinks, okay, we need to call this action, that time it will trigger. And the next difference is a workflow. Always a workflow doesn't need the AI reasoning, but the agent flow always required the AI reasoning. And this kind of workflow is good for the repetitive tasks, and the agent flow is best for the goal-oriented tasks. If we mention the example, let's say you need to upload one file to the SharePoint, then you need to send the notification to the teams. In that cases, the workflow is the good option or good solution. But if you think, okay, maybe we need the AI agent to decide, do we need to call the flow or not? In that cases, it's good to call the agent flow. We need to make the agent flow. Okay, now when we should choose the right tool for the automation. So now let's bring everything together with a simple decision framework. Let's say if your goal is to help the user complete tasks more efficiently, use the Copilot. Copilot is ideal for the productivity and the assistance scenario. But if you know that every step of the process or the path never changes, in that cases, it will be good if we use the workflow. And finally, if the agent needs to perform the business actions such as creating the uh, ticket or sending an email, in that cases, you can create the agent flow. Okay, now let's look at the solution that we will demonstrate in the lab today. So the process is start with a customer. When the customer will raise an issue or ask and help, then user will ask to the IT support agent. Then the IT support agent will use the knowledge base. If the information is available, it will classify the severity level. Then it will show all the solution, the best solution in front of the user. If the user, and every time the AI agent will ask the user, is your issue is solved? If the user reply yes, then it's okay. But if the user replied by no or negative answer, then the AI agent will automatically create the support ticket. I will show within the demo. So within the lab, there is a 5-step. I will show one by one. First, we will create one agent by writing the prompt, by using the Copilot. Then we'll upload the knowledge base. After that, we'll create one Power Automate flow. And that flow we will add into the Copilot Studio. After that, we will test it. Let's go into the Copilot Studio. Can you see my screen? I am opening the Copilot Studio UI.
Yeah, we can see that there, yeah.
Okay. So when you will go the Copilot Studio homepage, you will able to see the two options. One is the agent and another is the workflow. Since our target to create the IT support agent, so we will create the agent. There is another option for the workflow. So this time we will type all the instruction, and the Copilot will make all the will make the IT support agent. So this is the instruction we need to write. So I'm saying you are an IT support agent, use the uploaded IT support knowledge base, then try to understand the customer IT issues, classify the issue by the severity level, low, medium, high, and the critical. Then based on the customer question, provide the troubleshooting steps. After that, ask the user, is their problem is solved or not? If the problem is solved, then it's okay. Otherwise, create the support ticket. And then return the ticket number and tell the user, okay, your support ticket is created successfully. So let's go back to again here. So I already made the flow, because when you will write the prompt, it will take some time to configure everything. So I made it earlier. So when you will write the prompt, when you will send to the Copilot, it will automatically make this AI assistant, IT support assistant. So you see the instructions all is built by the Copilot. And after that, I just uploaded the knowledge base. This is the knowledge base PDF I uploaded here. And I created one SharePoint list to store all the information when the ticket will create. And then this is the ticket. I mean the topics for the support ticket. It's also created by the Copilot. So the first step, we need to write the prompt. When you will send it, it will automatically create it. Then we need to upload the knowledge base. This is the second step. And the third step, we need to add the Power Automate flow. So what is happening here? The AI agent is sending to all the customer response to the Power Automate. Then the Power Automate is created one ticket number, unique number, and then it's storing all the information within the SharePoint and then return to the ticket number. Let's try to execute. So I'm asking, my laptop is showing the blue screen every time when I start it, and so I need to resolve this issue as soon as possible. So let's see what it does. So it just identified the severity level is high. So it's just providing some of the solution from the knowledge base, and it's asking, did this steps resolve your issue? So I'm saying no. I need to create support ticket. Okay, now it's asking my name, email address, severity level, and the issue description. So one by one, just inputting the information. So this is the issue. Okay. So now it's trying to create the ticket. It's showing the support ticket is created successfully, and this is the ticket number and all the information what I have given here. So the AI agent is asking to create the support ticket. Now it's created. This is the AI agent is doing. That's all from my side today. Any question?
Great presentation, great demo. We have on the screen there from Dan, great demo. And it is great to see when the demos work. Anybody, any questions for?
Oh, no, thanks. Great demo. That looked awesome.
Superb demo. Really wonderful.
Yeah.
Thank you so much.
Very good. So, who's next up? Sahara.
Hey, hi Frank, how are you?
Not too bad. Do you want to share your screen there with us?
Yes.
Yes, so when you press on the first button down the bottom there with the cross on it, you get another option to share screen, and then up on the top, share entire screen.
Yes, it's uploading the PPT. Just give me a second.
Yes, so you'll get a little picture up on the top, and it says share entire screen.
Oh, okay.
I think he's uploading his PowerPoint, Frank.
Okay.
There it is.
Yeah.
Yeah. There we go. We can see it there now. Carbon Aware AI on Azure Intelligent Workload Optimization.
Yeah. Thank you for giving the opportunity today. So we will discuss about Carbon Aware AI on Azure Intelligent Workload Optimization. So one of the key, I mean, we have a lot of data in terms of knowing the carbon emissions and but as the cloud migration is going on, so still the carbon aware AI is not catching up, I would say. So we'll see how to address that problem and make sure that it is part of the architecture rather than treating it as which is not part of the architecture. So we'll look into those. So as I have mentioned, so cloud adoption is accelerating at a very huge pace, but the carbon problem is still not addressed at root level. So today we will discuss about these points. So what is the problem, and then what are the signals that feed the that can be utilized to address this problem, and the framework on how to utilize the signals to reduce the carbon emissions, and then the architectural layers of the solution and how it can be governed, like in terms of having an explainable AI to show the data or to show the outcomes that the architecture trying to solve, and how the practical roadmap on Azure looks like. So traditional scheduling, as you can see, they are mostly tailored to latency and cost, but not on the carbon impact. So what we suggest is to make a carbon aware scheduling so that it incorporates real-time data in terms of the efficiency of the grid and all the signals that real-time signals that feed into the system. Using those, we can schedule the workloads in such a way that the emissions can be reduced significantly. And as a runtime metrics, I think we can use the AI-driven optimization here to predict in future, like 6 to 24 hours in future, rather than using the runtime metrics alone, so that we schedule the workloads much in advance using the AI predictive models. So that should be the goal. And as you can see here, so there is a lot of data available in terms of understanding the carbon load or carbon emissions. And as you can see here, so there are the main metric is here is cooling efficiency. And if you see service level objectives, those play a major role, service level objectives, because we will understand which of the workloads can be deferred or moved or migrated to a different region or based on the service level objectives as well. So if SLOs are very strict, they may not be applicable for the carbon aware migration that we are talking about. And the other, as you can see, grid forecasts, renewable energy availability at that particular location where the workload is being deployed, and regional carbon intensity, all these points, they are available already. And as you can see here, so the flow or the scheduling can be done in a carbon aware AI system. But to do that, we need to classify what workloads are suitable for this migration or deferral. So we need to initially classify all the workloads which which can be migrated or which can be used by the system. So some of the workloads, if they are GDPR restricted, or they have very strict SLOs like we discussed, so those might not be classified as applicable for this kind of architecture. So that classification will give us a picture on which workloads are suitable for this. And then the forecasting, like we discussed, so we can predict the carbon intensity and renewable energy availability 6 to 24 hours ahead, so that the workloads can be distributed accordingly. And then we can then schedule the workloads based on those details. And then validation is something like once the workloads are scheduled that way, so we need to have a mechanism to measure what is the impact and then validate them against the previous metrics, so that we can see the results and better the system. As we discussed, so the prediction here matters, because instead of using runtime metrics as it is happening, so if we use the at runtime, so there might be there is a huge chance to improve using prediction 6 to 24 hours out, and that way it can be better utilized, the scheduling mechanism. And this scheduling takes account the warm-up time and migration latency as well. So here, as we discussed, so not all workloads are created equal. Like we discussed already, the time-critical ones, so which are having real-time APIs and user-facing transactions, basically, and latency-sensitive inference, these are not eligible for carbon deferral. So the deferrable batch. So here, if you see the training jobs, data pipelines, reports, backups, so these are all happening in the background, which is not directly impacting the SLOs in terms of, because these are not user interfacing. So these are very high opportunity for the temporal shifting. So, and the geo migratable, so certain workloads, there might be some data workloads which have very strict data compliance or data residency requirements, but there can be there are huge number of workloads which doesn't have very strict data residency requirements. These are highly eligible for spatial rebalancing. And the sovereignty constraints. So these are like the data loss, like Arun also mentioned, there are different data loss across different countries. So when we have very strict laws, we can only do the carbon scheduling within the region. It cannot be done outside of the region, which is a constraint, but still it has some scope here for having the carbon carbon-aware scheduling. So in practice, so as you can see, carbon-aware SDK is one which is Azure native tooling already has. So this will be this will have all the carbon intensity per region data, and then the main thing that we need to do before going for the carbon-aware SDK is to flag or tag the workloads. As some might not be applicable, some are very high probable candidates for the carbon-aware scheduling. So the tagging is something that we can already do when we deploy the workloads. So once these are tagged, we can use the data, and then emission attribution is logged per resource, like very detailed like metrics are available in Azure, so that we can understand what is the level of emission attribution is per workload. So these are already having in the Azure ecosystem. So as you can see, these are like data protection constraints. So some data or some of the data loss prevent us from migrating the workloads to out of the region. So identifying the right workloads for the this scheduling can help us like make sure that we are compliant with the actual workloads and not blindly apply the scheduling. So governance. So having the technical ability to migrate the load to a different region and based on the tools that we already discussed is not alone sufficient. It needs to have governance at scale, which make sure that these 5 pillars are which are presented here, they are compliant with those issues, or compliant in terms of data sovereignty, emission attribution accuracy. So legacy modernization. So some legacy applications, they might be more carbon intensive to refactor than just to shift them. So we need to be aware of those, and then the responsible AI principles for fair, and the AI should be explainable, fair, and auditable for each and every decision that the carbon scheduling system takes. It should be auditable through logs, and then it should be fair, not to like target a specific user segments to migrate to a high latency regions, and it should not be like that. It should be fair, and it should be explainable, like each and every decision, why it is taken, and what is the reasoning behind that. The prediction and AI reasoning should be able to explain those issues, and that is how we'll make sure that everything is governed, not done at random, so that it can be scaled to any kind of workloads. So here the principles of ethical carbon optimization. So like we discussed, so transparency and fairness are the two things that the AI prediction and it should handle these really well. And then we should have the human oversight. Like if it is, we should have the capability to override the scheduling, carbon-aware scheduling by a human, so that it can be monitored and done correctly. And then accuracy is something that emission attribution must use verified data sources to get the emission attribution and disclose the methodology clearly, so that the carbon optimization is well done. The practical roadmap on Azure. So as the roadmap you can see, first thing is to classify the objects which are suitable for the carbon-aware SDK to be used on those ones, and then baseline the emissions that are currently being done with without this schedule. So how is the current emissions looks like, and based on that baseline, then you can classify the objects, so that if they have very stricter SLO, they may not be suitable. Like if they have GDPR or other data laws applied, then those may be something that can be done within the region but not outside of the region. So those are the classification that needs to be done, and then the actual scheduling can be deployed, and then policies needs to be written around that, and enable the predictive forecast. So once this is done, the final stage is to report on what how it looks like against the baseline that has been done, and then if there is a decision made to migrate the workload to a different region where the carbon emissions are can be lowered, why that decision is taken, all the feedback or the reasoning should be visible, and so that it can be governed well. And as you can see here, so Carbon-Aware SDK is the open source library in collaboration with the Green Software Foundation. Microsoft Azure has developed to give us the carbon intensity per Azure region and to the lowest possible level on Azure workloads. And Azure Monitor and Log Analytics, these are the ones which allow us to monitor. And AKS has, as you can see here, the event-driven auto-scaling. So if it is decided that there is a better region where the carbon emissions are low, then that the event, once the event is triggered that this has high and there is a better possible schedule available, then AKS can determine that and deploy the containers there. And finally, the Azure policy. So you can enforce the scheduling guardrails and data sovereignty boundaries as code. That is the Azure policy, so that everything is as code, so that the governance layer is well made. So final is it is. Many of the teams that have Azure workloads, they don't treat carbon emission as a first-class citizen for the architecture. So having the ability to do, or having the ability to schedule the workloads based on carbon should be within the architecture as a first class constraint, along with latency and cost. And then the classification is really important on what kind of workloads can be utilized by the carbon aware scheduling. And then governance is not optional, because this is where we can actually visualize and govern what is happening in the scheduling and in the entire pipeline. That's it from my side. Any
Great presentation, and it's great to kind of see that like Azure has the ability to track all the carbon from all the different workloads. Yeah. Any questions from anyone there? Yeah, I was looking at, I'm not sure, are you familiar with the data center in the US? It's in Utah. Yeah, so it's got, the power is 9 gigawatts, which is incredible. I looked up its carbon footprint, and it's something like 35 million tons a year, which is actually more than the country. Like, I'm from Ireland, we're a small country of 5 million, and our carbon, the whole of the country is only 32 million. That one data center is 35 million tons. It's incredible. Okay, so our next speaker there is Ravi.
Yeah, hi. Let me share my screen.
Okay. Yep, I see it there now. Yep, we can see it. Yep.
So yeah, hi everyone. Thank you for Azure and AI Show. My name is Reddy Mandala, and today I'm going to talk about operating AI at scale on Azure, from GPU provisioning to production grade reliability. So I want to start with a simple observation. Most AI conversations begin with models, benchmarks, or prompts. Those things matter, but once an AI capability moves into production, the real challenge becomes much broader. So the question is no longer only can the model answer. The question becomes, can the system answer reliably, securely, quickly, and economically for real users? That is where Azure operations, platform engineering, and reliability engineering becomes central. So, so the goal of this session is practical. I'm not going to treat AI as lab experiment. I'm going to treat it as a production service that must be designed, deployed, monitored, and continuously improved. So let us frame the problem first. In early AI projects, the model gets most of the attention. Teams ask which model is best, which prompt works well, which embedding strategy gives better retrieval, or which evaluation data set shows improvement. So those are important questions, but they're not sufficient. They're not sufficient for production readiness. And production AI fails in places that are not always visible in a demo. It can fail because GPU quota is not available in the region where users need capacity, or it can fail because a node pool scales slowly during a traffic spike, or it can fail because of a model release changes output behavior in a way that looks technically valid but creates a business risk. So this is why the operating layer matters. So around the model, we need capacity planning, data movement, latency control, rollout safety, security, and fast recovery. So this is especially true for GPU backed AI systems because the infrastructure is expensive, scarce, and operationally sensitive. Yeah, so here's a path we'll follow. First, we'll look at the reference architecture for a minimum viable AI platform on Azure. I use the phrase minimal viable intentionally. I do not mean simple or incomplete. Second, we will focus on GPU provisioning, like where capacity is not just an infrastructure topic. Third, we will look in, about deployment choices. Not every workload belongs on the same serving plane. Azure AI or custom GPU serving. All these are different topics in the agenda. Now let's move to the reference architecture. So decide on a high level, so where a user or a client application comes through an API gateway or application layer, that request may go through authentication, authorization, and policy checks. Then it reaches the orchestration layer where the system decides which model to call, or what context to retrieve, which tools to invoke. And under that layer, we have the model serving layer. Depending on the use case, this could be Azure OpenAI, Azure AI Foundry model endpoints, or even a custom serving stack that can use that might be using a GPU node pools and all. So around that, we need data stores, vector indexes, feature stores, prompt templates, configurations, secrets, and policy services. So the important point is that production readiness is not created by one component; it is created by the boundaries between the components. So, for example, what happens if the vector store is slow, or what happens if the model returns a refusal? So, what happens if a downstream system times out? A good AI platform makes these questions explicit. It separates concerns so teams can evolve the model without breaking the runtime. GPU provisioning. So in traditional web services, we often treat compute as elastic and relatively easy to scale. But in GPU-backed AI systems, the assumption can be dangerous. Like the GPU capacity can be limited by region, by quota, SKU availability, cost constraints, and provisioning time. That means capacity planning has to be part of the reliability design from the beginning. On Azure, this can lead to several design choices. You may use AKS GPU node pools without auto scaling. You may separate system node pools from GPU workload pools. You may use taints and toleration, so only the right pods land on the GPU nodes. You may use cluster autoscaler and capacity reservations where appropriate. The most important operational question is what happens when the preferred capacity is not available. A strong design has fallback options. That may mean a secondary region, a smaller model, a quick path, a CPU fallback, or a graceful degradation in the product experience. So this is why I call GPU provisioning a reliability dependency. Users do not care whether the outage is caused by a model bug or a quota issue or a saturated node pool. They experience all of those as the same thing. So the AI system is not dependable. Capacity should be monitored, forecasted, and tested like any other production dependency. So once the capacity is understood, the next question is where to serve the workload. Azure gives multiple options, and the best choice depends on the level of control and responsibility your team is ready to own. If you use Azure OpenAI or managed model endpoints, you get a strong management. That's usually the right path when you want fast adoption, enterprise controls, and less operational burden. And if you use AKS with GPU node pools, you gain more control. You can bring your own serving stack, tune batching, managing model containers, control networking, and integrate deeply with Kubernetes operations. So the decision should not be emotional or trend driven. It should be based on the operating model. Like ask like how much control do we need? Like how much operation burden can we support? So a mature organization may use more than one serving plane. The key is to make the choice deliberate, documented, and observable. A safe AI. Safe AI release is not just a deployment; it is controlled experiment. This matter becomes AI like changes are often which are behavioral, which are not even technical. A new prompt or a new retrieval configuration or a new model version can change outputs in subtle ways. The service may remain unavailable, but the answers may become less useful or less grounded. So that means release gates must include more than the unit test. Production A release should start with immutable artifacts. The model version, a container image, a prompt template, policy configuration, retrieval index, and evaluation set should be versioned. If something goes wrong, we need to know exactly what changed. So observability is another area where AI systems need a broader view. So in traditional systems, we often start with the golden signals like latency, traffic, errors, and saturation. Those still matter. For AI systems, they are necessary but not sufficient. A GPU can look healthy while the user experience is poor. The API can return 200 okay while the answer is not grounded. A retrieval system can return documents but are not the right documents. So we need observability across the full user journey. At the infrastructure level, track GPU utilization, memory, queue depth, pod restarts, node availability, and auto scaling behavior. At the application level, track request latency, model latency, retrieval latency, timeout rates, retry rates, and failure categories. And at the AI quality level, track grounding, citation quality, refusal rates, user feedback, and evaluation scores. The best telemetry connects these layers. For example, if cost per request increases, we should be able to see whether it came from larger prompts or more retrieval calls or a model change. If answer quality drops, we should be able to see whether it came from retrieval or prompts, model behavior, or even any stale data. So now let's talk about reliability patterns. So production AI reliability is not one pattern. It is a set of patterns applied at different layers. First, design for graceful degradation. Second, use retries carefully. Third, isolate workloads. Fourth, define service level objectives that include user outcomes. Fifth, the test failures where the simulate capacity exhaustion or region degradation. comes. Overall, reliability is not the absence of failure. Reliability is controlled behavior under failure. So cost is often discussed as a finance topic, but for AI systems, cost and performance are reliability levels. When interference cost becomes unpredictable, teams may reduce testing, weaken redundancy, or avoid running evaluations. That creates operational risk. So cost controls starts with visibility. Know the cost per request, cost per user journey, separate experimentation from the production, track the token usage, prompt length, output length, and all. Performance tuning also matters. Batching can improve throughput, but may increase latency if misused. Caching can be powerful, but only when applied safely. The operating principle is simple. Do not treat cost as separate from reliability. A system that is too expensive to test, monitor, and recover is not truly production ready. Governance. So security and governance must be part of the runtime. They should not be the documents that sit outside the system. In production AI, the system should enforce identity, access, data boundaries, policy checks, logging, and auditability. So when an AI incident happens, teams need a playbook that diagnoses by layer. Otherwise, everyone jumps to the model as the cause, and what is often wrong. When an AI, so let's say if any system AI system is unavailable or slow or giving poor answers, giving unsafe answers, or failing only for a specific workflow, then map the symptoms to layers. So at the traffic layer, look at request volume, rate limits. At the orchestration layer, look at the tool calls, prompt assembly. At the retrieval layer, look for index freshness, search quality, document permissions. At the model layer, look at the endpoint health, model version, token limits. At the infra layer, look at GPU nodes, pod placement, memory pressure. So a strong incident process has predefined dashboards, owners, rollback steps, and communication templates. It also has post-incident learning. So for AI systems, incident response is not only about restoring uptime, it is about restoring trust. Users need to know what the system is dependable, and the teams need evidence that the same issue will not repeat. So this is a maturity model helps teams understand where they are. So at the demo stage, the system is often manually operated, light tested. At the pilot stage, teams add basic monitoring, access control, and initial evaluation. At the production stage, the system has defined owners, release gates, telemetry. The teams can deploy changes safely and recover from problems quickly. At the optimized stage, the system continuously learns from feedback, evaluation improves over the time. The reason this maturity model matters is that it prevents false confidence. So production readiness checklist. So this is a checklist I would use before calling an AI workload production ready. Capacity plan. Do we know quotas, regions, GPU pools, fallback capacity, release gates, our model versions, prompt versions, retrieval configuration, reliability. Do we have a graceful degradation, fallback paths, workload isolations? So if a team cannot answer these questions, it does not mean the product is bad. It means the product is not finished. Production readiness is a discipline, and this checklist makes that discipline visible. So let me close with the core message. The production AI is an operating discipline. the organizations that will not only have better models, they will have better control planes for capacity, release, reliability, security, cost, and learning. The model is important, but the model is not the whole product. The product is the full experience, like how users access it, how context is retrieved, how inference is served, or how latency is controlled. For teams building on Azure, the opportunity is powerful because the platform gives us many building blocks like managed AI services, um, GPU node pools, identity, networking, monitoring, policy. Um, so my practical recommendation is this: before scaling an AI system, review the readiness checklist, identify the weakest layer. Is it GPU capacity or release safety, observability, cost control, or incident response? So fix that layer before traffic exposes it. So thank you for your time. I hope this session gives you a good info about moving AI from impressive demos to dependable production systems. I'm happy to take any questions.
Very good presentation there, Ravi. The whole session was nearly around Azure today. So anybody have any questions there for Ravi?
Another great session.
Thank you all.
This has been excellent so far today.
Very good speakers today. Yeah. And we have Dan Ray up next.
Okay, let's see if I can share my screen here successfully. Okay, so I got a build of Windows that allows you to move the taskbar around finally in Windows 11. So if you want it at the top of your screen, which I've used primarily for when I'm demoing something start menu related, and I want it at the top of people's screens as opposed to at the very bottom of the screen. I can move the start menu around to the left, which I find super valuable on a Surface device. I have my Surface device in portrait mode, so the camera was acting a little funky, so I turned it off. But the benefit to this is when I'm using it in portrait mode, if I put my taskbar to the left, as opposed to the top or the bottom's where it normally goes. The bottom doesn't give me a lot of screen real estate. And in Windows 11, you can't resize the taskbar, so I can't just automatically make it bigger. But if I put it to the left, notice that it gives me plenty of space because that's the long edge of my computer. And so as a trainer that occasionally uses a portrait mode orientation, especially for reading, anything that's more lengthy than wide, I have typically at least one monitor that's in portrait mode. And what I found in Windows 11 was having the taskbar always at the bottom caused me some issues with just size and placement. So in Windows 11 build 26.300.8553, they buried the ability to change this. And that was the thing that took me the longest amount of time to find under system, or it might be under Windows Update here. Home, Windows Update at the bottom. Where are you? Are you under system? Maybe I can search for it. Let's see if we can search for update. There it is, Windows Update. I had to go into, I believe, Insider Program, make sure I'm in experimental, and then the feature flags is where I had to enable the alternate taskbar position. So I had this build, couldn't see the ability to change the orientation, and that was because I had to find this Windows Insider feature flags to enable, and it looks like there's several others that I can enable to do some testing of. But Frank, I figured that might be of interest to folks, whether they're using Surface like I am, or if they're just using portrait orientation or have another reason that they like to reorient the taskbar to different locations on their computer.
Yes, very good, Dan. Especially where you can put the
Neat
task
trick.
over to the left or over to the right.
Yeah, it's been super helpful. Took a while to find.
I don't know why they always have to bury these things. That's just super. I'm glad you found that.
Yeah. So Hal, if you're on any type of Windows device and you put yourself into an insiders category, I think you have to be in either the beta or the what's the other ring called? I think it's the beta or the Canary build rings, and then you go to feature flags. That's where you can get it.
Mm.
Frank, are you using Insider's build, or are you using just regular Windows 11?
Just regular Windows 11, yeah.
Okay. Yeah, I'm hoping they'll give you the ability to switch it in ways by dragging it, but right now it looks like you have to go to the settings to actually switch where the orientation of the taskbar is. So it's right here when you get into it, personalization, taskbar behaviors, taskbar position. And then it also has the left or the center for the icons. And then I think it was under another setting to make the icons bigger or smaller. Might have gone in. Yeah, I went in here to make the icons bigger or smaller.
Yeah, that's definitely important for people who have problems with their site anyway, you know?
Yeah.
Yeah, definitely.
Yeah, good point. And I like the background here. I don't know if this is one of the new experimental ones or if it's it's probably just one of the B.Eng ones. But some of these backgrounds are really nice.
Yeah, they look like the B.Eng ones, right?
Yeah. I've still got the recall features on here too. So recall should allow me to go back to all these screenshots of our meeting, getting into StreamYard. I went live on StreamYard yesterday to show this off. So I've got screenshots of various things in Windows Recall, which is another Windows 10 feature on some of the new Copilot Plus AI PCs. Hal, I missed last week. I saw your story, though.
Yeah.
I have radio stuff. That was really interesting.
Got to remember to hit the mute button. Yes, I'm glad you like that.
Yeah.
Back in regular portrait or landscape mode.
Yeah, so that was interesting about the ham radio on RF last week. Yeah.
Yeah.
Different spin on things.
Definitely.
Yeah, I had a lot of speakers lined up, but it's like they didn't turn up at the end, so it's just one of those things.
I warned Hal about that. You know, it's sometimes there's not room for squeezing in another guest, and sometimes there's, well, now it's just the two of us, or just the one of us if you're the only one there.
That's right. I remember I done the St. Patrick's Day one year when I was on my own, and I had my St. Patrick's Day hat on me. Yeah, it was funny. Talking away on my own for the hour, but I had stuff to present, so it was okay.
Goodness.
So we have the.
I don't know if I've got that much chatter.
We have the Microsoft. What is it? The AI Fest starting on
Is that next week?
Monday.
Monday. Okay.
This Monday. So if anybody wants to get a free Credly badge, or if they want to get a free voucher for an exam.
Here's some view.
I think they have it online there. Will I just share it there? Then or can you bring it up there?
Is it an example banner?
No, they have a website. Actually, I'll give it to you there. I'll put it in the chat. In the private chat there. I just pasted it in there.
Yeah, let me see if I can toss that in as a banner.
Oh, slick.
It doesn't look like it's taken from my touch. Let's see if I can use the keyboard to do it. Copy link, banner. There we go. Then I can probably add it to your link, Frank. So I think that's on your. I think that'll be on your LinkedIn. Not sure why it's not showing up here though. This is your Azure and AI Show one. Let's see if these are coming through. Yep, there they are. So I should be able to go to the studio, grab this link. Paste it here. I think that should show up on the screen. It's weird. Some of the hyperlinks aren't showing up for me for whatever reason, but the scrolling or the.
Yeah, I can see it there now. Yeah.
Okay, cool.
Yeah.
Yeah. And I know Juneteenth, we're doing a big event in Chicago on June 19th, Friday, with a bunch of techies. AWS will be there. Microsoft will be there. Former Microsoft folks. There's 6 presenters. And the theme is building our own table.
Okay. Sounds interesting.
Yeah. It should be a good time. Last time they had it was 3 years ago, so it's been a moment since we've met in person. But we had over 50 people the last time, so I'm hoping to surpass that number this year.
So the AWS and Microsoft do collaborate.
Yeah, AWS was, one of the presenters presented 3 years ago. So she's returning. And then Erin Hunter, I met this spring at an AWS event with the AWS Community Hero. There's a few MVPs that have both the AWS Community badge or credential or award, as well as the Microsoft MVP award. And so I reached out to Erin Hunter and said, hey, there's this event in Chicago. He applied for the call for papers and is one of the 6 speakers that got selected. So I'm happy to participate. It'll be good to see Aaron again. He's a really good presenter.
Very good.
Yeah. Thanks, everyone. Looks like folks are dropping.
Yeah. So we'll end the live stream there. So if anybody doesn't have anything else to share.
See you all next week.
Yeah. See you later, Hal. Bye, Frank.
We'll be back here again.
Great show. Again, thank you, Frank. Thank you.
Thanks, Hal, for joining. Appreciate it. Thanks again, Dan.
Yeah.
Okay.
Thank you, Dan.
The live stream. So